So thank you so much for joining today's session. And my name is Mitesh Vora. I am associated with Edureka for quite a while. Today's session is on how do you prepare yourself for interview on Splunk topics. Now that's one of the hot subjects in the market right now, and we see a lot of job opportunities rising in the market. A lot of people hiring Splunk. The way Splunk is getting adopted across various different industries and domains has been continuously growing. The capabilities of the platform are rising higher and higher, and hence you see a lot of opportunities for job seekers as well as the organizations to build up those skills. Some of the primary roles that we see in the market is around Splunk Architect to design and plan deployment to see how your data structures are. The other side is on Splunk Administrator. Once your environment is built up, and how do you maintain that, going on integrating with different systems, different parts of your organization from the IT and non-IT perspective. And then you see a lot of development happening. So you can leverage Python, Perl, PHP, Java, JavaScript, C#, .NET skills, bring them onto Splunk, and then enhance the capabilities of the platform. So a lot of roles getting built up, getting churned out, new roles, new designations coming up into organizations on those lines. So we see a lot of growth over the past few years within the Splunk technology. And one of the reasons and one of the areas where we see a lot of growth is more into finance and insurance, banking, BFSI as it's called in India. The other areas are also into IT, retail, trade services, hospitality services. A lot of things, a lot of domains are adopting them for a variety of reasons and a variety of purposes. So we are on the areas where Splunk is getting adopted very rapidly. And the primary reason is that the flexibility the platform offers gives a lot of visibility into what's happening into the network, the packets, those ones and zeros on the environment. And that also allows the organization to make sense out of that data, the jargons, those cryptic information. From that perspective, a lot of areas where Splunk is getting rapidly adopted. And today what we're going to see is how do you prepare for an interview, either from a perspective of an interviewer or from an interviewee as well as a participant. So basically we see this, a discussion, I would say more of an interaction where I'm happy to receive more questions and take them along the path. This is more to do about, what are the questions, but coming from an industry experience of 20 years and working with Splunk as well for a few years, I would say, I would like to bring in a perspective about what is the best answer out of all the right ones. So that's what more about it. I'm happy to take more questions if they're not covered out here. We can definitely have another Q&A towards the end of the session. Keep putting them in the queue box and I'll keep taking them up as and when we progress forward. So basically, the first question that always comes up is, what is Splunk? Or rather, if the person is already certified on Splunk and does something, then he would want to understand, the interviewer would want to understand what is the perspective, what is his understanding about Splunk, why is it being used to analyze machine data. Now here it's very evident that yes, of course it is a platform. Now you keep this hearing a word platform from a lot of Splunkers or ex-Splunkers. We would never call Splunk as a tool, we'll never call it as a product. It's never a solution as well. It's not a silver bullet as well. But it's more of a platform which allows people to get visibility into machine data. Now, machine data is something that is getting generated by devices, the server, software, hardware, a lot of things. And basically, it is all about getting the data into a single platform and to analyze that and make a single source of truth from which you can make sense and build up different use cases like application management, IT operations, security, compliance, fraud detection, threat visibility. A lot of things are there with Internet of Things coming up. You could look into your GPS, RFID, thermal sensors, and a lot of things are being getting pulled into. In fact, people who are wearing smart gadgets like Fitbits and Garmin's, even they can be splunked and you can get your health. There are people who would even go ahead and look at their Outlook data and see how well efficient time perspective, time management is being done for themselves for their day schedule. So Splunk gets data from any machine data, any source, any volume, any variety, and in any volume. So it's not limited to the number of devices, number of users that are connected to it, number of use cases that you can build, number of Splunk instances that you can spin off. So there's no limitation in such. The only area where Splunk licensing is about the volume of data that comes into a 24-hour window. So Splunk is basically used to get data into any unstructured data, any structured data, bring it onto a single platform, build it into a source of truth, and then get visibility of your intelligence or operational intelligence, and thereby take a timely business decision on top of it. So that's the main objective of getting data into an organization, right? So when we get data into a platform, you want to take business decisions, whether you want to make a capital investment on new server, new data center, or new service provider, or do you want to leverage an existing one, like what happened with virtualization technology. You had loads of physical hardware, then you started consolidating them onto a virtual platform. The same way, you want to get more and more visibility into your investments that you have made for your business, and Splunk allows you and helps you in making those decisions, getting those visibility. So that's more about what Splunk is and how it is being used for analyzing machine data. The next question that typically comes, of course, is then how does this really work? How does this whole thing build up? How do you get the data in? What does it do with that data? Where does it store? How does it compute all those things? So that's the whole thing. So here it's how a typical data flow would be into Splunk. There's something called as a forwarder, which is also a dumb agent. Just picks up the data and then sends it to something called as an indexer, which extracts, builds metadata around each of the information that comes in, and then it segregates that as an index, which is like either an index of an RDBMS or it's an index at the back of a book, like certain keywords which have page numbers where they occur, and thereby when you're looking for a particular word, you do not have to go through every page. You just to refer to that particular index and jump straight to that page number. That's exactly how an indexer really works. So the indexer really builds up that kind of metadata and those raw data mapping, and then stores them onto the disk. And then subsequently, it uses that information, the metadata, to retrieve and search information as it is being queried from the web interface, which is also called as a search head. So that's typically the path through which the data comes into an environment. So the forwarder could be either a remote forwarder where people are hesitant to install those kind of agents on something like an Active Directory or a mission critical system like an SAP or something. You can pull data remotely. So using a forwarder, you can capture data from various different network appliances, collect them on a jump host like syslog-ng or on our syslog box, put a forwarder on that, and then transmit the data into a Splunk instance. So that's typically how data flow happens within Splunk. So what are the different components that play a role and then make up an environment in Splunk? So what's a typical architecture view about it? So this is how a pictorial graphic representation looks like. So you have data inputs looking at various indexer forwarders. The data is then load balanced, which is automatic and out of the box, onto different indexers, and then it is presented on the search head as a user keys in the queries, which is very similar to what Google interface looks like. And of course, it runs on a technology called as MapReduce, which was introduced by Google in 2004. So you have that complete data flow, and the main components being the search head, indexer, deployment server, and forwarder. With a larger environment, you need, it is more like the deployment server, you can call it more like an antivirus policy server, which where you have exceptions, where you have different connotations, where you have different groupings. The same way a deployment server allows you to map and create different set of data collection policies, whether it is a Windows-based server, whether it's a Linux-based server, Solaris-based server. A different operating system, different application will have different connotations, path naming conventions, machine naming conventions, and you want to collect different set of data from different machines, and all those policies and set of settings could be put on deployment server, and you can manage them centrally. And that's what the whole thing looks like from a top level. So the main components from a Splunk architecture and a deployment would look something like this, and that's how the data flow happens. So going forward, the next step is like, yeah, I do hear a lot of this, then what are the alternatives? Why Splunk? Why do you think that we should go for a certain thing like Splunk? Why can't we do it ourselves? Why can't we build something home? Why can't we use open source? Something similar to what happened to a Windows environment to Linux. Of course, that went well, and you see a lot of commercial Linux doing much more better than open source platforms. The same way, Splunk has a lot of competition. It has competition in doing log management. It has competition in doing business intelligence. It has competition in looking at IT operations. It has competition in doing application performance management and other things. It also has competition in IoT as well. However, there's not one single platform, product, or a tool in the market which can do all of these from a single perspective out of the box, and that's exactly where Splunk scales. So you have scalability, you have all the use cases that can be built on top of it, as well as you have a professional support and a company backing the platform. All of these put together, Splunk has a lot of competition, not that it does not. You see a lot of them in the market. You may hear Sumo Logic or Logly in the cloud space, log management. You will see ArcSight or QRadar from IBM's in the SIEM space as well, the security and fraud detection management. You will see a lot of them from things like AppDynamics or CompuAir, Dynatrace, and things like that. However, all of these put together, they would have their own strengths as well. I see a hand coming up. Certainly. Yes, Rajesh. A question in distributed environment, feel free to put it in the box here. I'm happy to read out. We do have some more questions coming up in a distributed environment as well. So you do see alternatives. However, there is not a one product, or the Splunk is just one product which can cater to all these needs. For example, if you were to collect network data, you can use it for network operations monitor. You can look at it from IT operations perspective. You can use the same network data for monitoring application latencies or end user experience perspective. You can use the same thing for security perspective as well. The same goes the other way around as well. If you're collecting web server data and trying to monitor the health of a web application, traditional legacy SIEMs are not designed to look at that data. Traditional legacy SIEMs are not designed to look at AWS data, whereas you can get visibility into billing and your infrastructure of AWS or Azure. And on the same time, you can build use cases like man-in-the-middle attacks or session hijacking from your web server data. Now that's the unique space where Splunk lands and expands. So Kepware is kind of a frenemy. Kepware does a lot of things on IoT. You see Google doing a lot with its Nest thermostats and connected home perspective. It is coming up a lot. On Google, you will see that. So they have their own challenges, they have their own limitations, but Kepware also works very well with Splunk as well. So you can get Kafka data into Splunk, you can get Kepware data, and you can visualize, monitor your IoT data. You can get smart meters as well. You can get thermostats. You can get the health of your telco tower and the things. You get that data as well. Sure, Rajesh. I'll take that question. Okay, I see that we have map reduce at all computation is distributed indexer. Results are merged into certificates. Yes. Search doesn't become a bottleneck. Good question, Rajesh. In a large enterprise organization, just as you can scale indexes horizontally, you can scale search heads horizontally as well. There was a concept called search head pooling earlier, which was dependent on NFS and had a big performance issue. Splunk did away with that, and they've come up with search head clustering. So you have a similar clustering environment in search head as well. So you can spin off SI. So I've seen a very, very large organization having roughly 17 to 18 search heads. So you can go that high as well, depending upon your geography, business units, and things like that. You could do that. So, all right, Rajesh has another question. Why not store data in HDFS and use Solar Elasticsearch? Well, you can do that, but then you cannot build that data that's not as quickly as possible. So if you look at it, the speed and volume at which Splunk can retrieve, because HDFS cannot index data. So we all know if your database is not indexed, column tables are not indexed, there's a big performance issue. And that's the same thing. So HDFS is just a batch storage. It's a cheap batch storage. Just put all your old hard drives and collect them together, and that's HDFS. Whereas Splunk works on HDFS, of course it does. It has virtual indexing capabilities, and it also works on solid state drives, and it is much, much, much faster. So if you look at it from traditional technologies which work like Solar or Elastic, they have the capability to get data very limited. On an enterprise scale, you would typically look at things like 10,000 events per second or 15,000 events per second. On recommended hardware capability, as a standalone as well, Splunk has a capability to start with 86,300 events per second. So you're now talking a different ball game, a different level of maturity altogether. So I haven't seen anybody reach that level. 86,300 events per second is what the benchmark test numbers are. Great question. Thank you so much, Rajesh and team. We move ahead. Basically, So a lot of questions around alternatives of it. So can we do that on a, how do we consolidate hardware? Coming back to the same question, how do you do this? How do how do you make sure that, because infrastructure is growing on one side, and then you also want to make sure that your investments are optimized. So there are certain roles that can be consolidated together. And what we see here is, you have various different Splunk roles on one side of it, like a search ad indexer, license master, cluster master, forwarders, and other things. There are, I would not say technical issues, but I would say strategically, indexers and searchers should have physical dedicated machines. It's not that they cannot be deployed on virtual infrastructure, but then we need to follow certain guidelines in pinning down compute resources, which at times the administrator is not really very happy about getting that request. Of course, there are performance known industry standard. It's not something related only to Splunk, but when we put any application or operating system onto a virtualized environment, the performance definitely degrades. And hence, what you need about just 2 or 3 physical boxes, you might end up having 20 virtual instances being spinned off to do the same job. Having said that, things like license master and deployment server can definitely be implemented on the same box and using a virtual instance as well. So you can spin off VMs for each of these. Cluster master, also you can put it on a VM. But deployment master and cluster master cannot work on the same machine, because the number of consistent and persistent connections coming to deployment server is much, much higher, because not only does deployment master cater to the set of searchers and forwarders as well, but it also has a large number of forwarders to cater to, which the cluster master does not have to. So we give that benefit to cluster master and keep it separate, and deployment master separate in that perspective. And then there are certain benefits of having forwarders in place. That's another reason why most people also ask questions about why forwarders, why do we need forwarders in place, where we can always say, ask my network appliance to just push the data into Splunk instance on UDP 5 and 4. Now, well, that's a great thing, but then scalability becomes a challenge. What if there is a network outage? There is no way you can get the syslog data, and you would never know what data is lost in that situation. And hence, it's always good that you consolidate data into one place, like a syslog box, a jump post, and then put a forwarder. Now, this gives you a benefit that your UDP connection is now converted into a TCP connection, which is a connection oriented. And apart from that, you also have the additional capabilities which are presented on the screen, like bandwidth throttling, TCP connection, SSL capabilities. You can secure your communication between a forwarder and an indexer as well. You also have an out-of-box, free-of-cost capability of load balancing. So in case one indexer is down due to network outage or for maintenance purpose, the data can always be redirected to another indexer instance in a very short time. So, and till that time really that happens, forwarder also has a capability to cache events for you locally within memory, and that's completely configurable as well. So you have certain benefits of using forwarders over not having those forwarders. And speaking to customer over an environment is always you end up convincing that person in terms of having forwarders. This is another question why it has to be very convincing. The person needs to know from an interview perspective that he has worked on forwarders and this kind of infrastructure, understands the capabilities really very well to come out with this kind of responses. So how do you put a complete architecture put together into a single slice together? While we saw about 4 or 5 slides together individually, a single architecture could be explained, and that's another thing more from an administrator and architect perspective that does really understand the architecture of the overall architecture of Splunk as a platform. So Splunk engine is divided in 2 different parts, basically getting the data in and then presenting it as well. So you have, prior to Splunk 6, that was 2 different services running independently. Splunk 6 onwards, they consolidated both into a single service, splunkd.exe. Or Splunk T, basically, whatever you call it as. So the Splunk engine also has the capability to present web interface, and that's connected to the Splunk core engine internally over REST API. And to explain this architecture, you ideally should be starting from bottom up. So you get the data from various different network ports, running the scripts, detecting file changes, and then monitoring remote files. And then you have that capability from a forwarder perspective when it comes in, that the data comes and you have the ability to either route the data based on certain rules that you can configure. You can clone the data in real time. And you also have load balancing. So cloning and load balancing are two different aspects. You can duplicate or create multiple copies of an event right at the data source, and that's called cloning. Whereas load balancing is like in case one fails, you hook over to the another instance. That's load balancing. Clustering is very different, so we'll come to that question already at a point of time. So you have that ability of doing this. You have a deployment server like we spoke about, managing the entire deployment, configuring policies and other things. And then the data, when it receives, it's stored in an index. Now the index is then broken down into various different, it's kind of different logical data stores. And at each data store, you have the ability to control role-based access control. So either it is native, you can connect to an LDAP like Active Directory, or you can have a two-factor authentication or scripted authentication like SAML or ping identity, ping federate. That's the current one that's supported. And then once this data is in, you have the ability to search and have a distributed search. Apart from that, instead of doing just ad hoc searches, you also have the ability to do scheduled searches and create an alerts on top of that. So whether a file came in last time or not, at 5 a.m. or not, you can create an alert. If there you find that there is more than one IP connected to a single session ID, then you can create an alert. So you have those capabilities. You have the capability to create reports on top of it, so you don't have to keep, so you can save those searches that you created, the queries, and then that's presented as a report. So you don't have to retype them all over again, hand it over to your customers, your management, and the people. And then the final module within the Splunk engine is called knowledge objects, where you enhance and enrich the unstructured data with a structured data. Like you find a user ID in your event, and then you can correlate that with your HRMS system to find who the real person is, who the supervisor is, which location, and other stuff. You can also get things like product ID to your product database, product name, product pricing, the complete product catalog for that matter. Or you can look up to a database and say that, all right, can I find, from a MAC address or an IP address, can I find the machine name and the user and the owner of it from a CMDB perspective? Can I find the configuration item and other details about it? So that way you can enrich this. One of the security use cases out here from knowledge objects is bringing in thread data feeds. That's the most common thing that you hear. And the entire environment is being visualized, managed over Splunk CLI, Splunk Web, and you can even write your own wrapper application around the Splunk engine using the SDK. So that's a very high-level view about the Splunk architecture. Now, we did stretch a lot, but predominantly, if a participant or can explain this in a short while, I think he has a good understanding of the overall picture. So what are the knowledge objects? So knowledge objects are basically, like we spoke, in terms of, you can create lookups, you can create thread data feeds into it, you can get data from a lot of government data is also open source and available for people and organizations to use them within their applications and their organizations. Like if somebody is more into physical security, then you would collect data for earthquakes, volcanoes, flooding, or economic sensitivity and other things. You would capture that data, and that's available on the internet. You can leverage that kind of information. You can leverage thread feeds data, free and commercial, both of them, and multiple of them. You could do that. You can get blacklist from spam blacklist or a DNS blacklist as well. There are people who build their own lookups as well, knowledge objects, and as well, like you want to monitor activity of people who are serving notice period. So you create a list of them and try and create a rule to flag out if they are trying to copy data outside. So those are the knowledge objects. You can tag informations, you can create event types and create search constraints right at the start and shorten them so they're easy to remember, they're easy to correlate and understand, rather than writing long searches and things like that. So all those constraints where you put your search conditions, you can shorten them into something called as event types, create tags around it. So I want to say that host 1 is a new server, host 2 is an old server, and host 3 is kind of a testing environment. You could do something like that, which is more meaningful and more understanding from a management perspective or non-technical perspective. So those are the knowledge objects within Splunk, which are very, very useful. And then comes workflow action. So you get all the data in, you understand the architecture, you have created rules, you have created reports and schedules. Then what do you do about it? So you can create workflow actions which automate certain tasks. So you can do a double click drill down into a contextual drill down from things like an IP address, and you can do a who is or a domain dossier on it. You could create something like, pick up an IP address or a web domain name and then say that you want to perform a further search that does it occur against more than one data source. Like if a firewall is there and you get an IP address, then do you want to find out that does this firewall really exist, or is this a source IP address on my firewall? Is it a destination for my endpoints? So are my endpoints connecting to this IP address outside? You could find out those kind of stuff. You could double click and say that, all right, I want to get a user name from my report and then pass this as a parameter to my next report. You can do that using the workflow action. So you have the ability of get as well as post. And you can also trigger things like creating a ticket into your trouble ticket system using workflow actions. So that's one way of looking at it. That's a very, so if a participant can explain a couple of use cases or even one use case, I believe, yes, he has understood and he has probably worked, because this is something which is not very well known. It is not used by an average Splunk user. This is something that somebody who really understands workflow actions, and only he would be able to answer a little more about it. So that's more of a screen of a workflow action. If the person can really explain this, even the bottom half of it where you have a URL to present, yeah, it opens up in a new window and what kind of a method. So you have a complete picture in front of you about how it looks. So you have, so in this example, it says that the title would be like get info for an IP address, pick up the field called client IP, show in the event menu, and then open up in a new window, and then go to what is my IP address with $client IP address. So you're picking up the IP address from your event and passing it to what is my IP address.com. The same way you can pass your latitude, longitude details to your Google map, and then you can find out where does this IP really exist, or this location does really exist. Data models and pivots are basically unified, or I would say a graphical way of writing your search queries. Now, people who have used Microsoft Excel are very familiar, and I would say the pivot feature is extremely similar to the Excel pivot and Splunk pivot. So the whole concept was taken up from there, and then it was built, written from scratch. It was a great initiative. Luckily, I've been a part of the team where we did read all this stuff. So data models are more about creating a structured hierarchical view about your data. So it's more about where you can say that you have a search constraint and then you create a hierarchical model about your data. So you have a purchase group, then you say successful purchase. Below that you will have a child object of a kind of a failed object, a failed purchase. Do you want to see a categorized way or things like that? So other ways you would say that you want authentication as a structure, and then you would be able to create model around a VPN, root access, admin access, non-root admin access, authentication on various different applications. So you create a structure around it in a way, and that normalizes the way you look at your data. So if I look at our data model called authentication, it does not matter to Splunk as to where that source is. And for a user perspective, it becomes extremely simple that as and when new data sources are added or old ones are deprecated, you do not have to rewrite all your searches. And that's the biggest benefit of using data models and pivot. With pivots, you have the ability to flexibly create different views of your results, and then pick and choose one that is the right, add the right set of filters that you want to add to it. And that's then both these options are aimed at non-technical business managers. I would say semi-technical business managers perspective. So data models and pivots are great features from that perspective. Going on to the next is search factor and replication factor. That's one of the areas where we're talking about clustering and extending the capabilities horizontally. Search factor, basically a question comes up when you are interviewing or looking at a role of Splunk architect, because this is where it falls into. So it's more related to clustering, whether it's search ad clustering or indexer clustering. The search ad clustering only has a search factor, and indexer clustering has both these concepts, SF and RF. Search factor is where do you want your data to, how many copies do you want to be searchable and Replication factor is how many replica copies of the raw data do you want. So search factor basically works only with your, you can access the data, you read it, and you have execute capabilities. Or replication factor is more about dormant data, and then you'll have to rebuild your index in case you have only one search factor. Okay, I see a question coming up here, which is great. Mr. Naga says that what are the best practices for clustering search heads or indexers? Do we need RF if we use Hunk then Splunk? Great questions. So first things first, what are the best practices for search head or index clustering? One of the things that you would see here is that you cannot have SF greater than RF. You cannot have a search factor greater than replication factor. That's number one mistake that people make. You just enter a number and then you forget about it, why it is so, and then we restart the cluster, the whole thing collapses. So that's important point that one has to keep in mind, and if it's an interview, then you need to make sure that you mention that fact. Apart from that, it's more about a use case and how much scalability you need. So you can even have a multi-site clustering as well. So there's a lot of documentation on the Splunk site and Edureka portals as well. There are a lot of blogs out there. Do we need RF if we use Hunk then Splunk? Hunk is deprecated. Hunk capabilities are now merged with Splunk. So there's no more Hunk product which is available to download anymore. So it's now called Splunk Connect for Hadoop. And the capabilities are premium capabilities, and it has the ability to roll your aging data into Hadoop and still have the capability to search it, which was not there earlier. So that's 6.5.1, which was released day before yesterday. See another question coming up. They deprecated Hunk from 6.5. No, I think the plan was to do it from 6.3 onwards. So we didn't see a Hunk binary separate. In fact, the Hunk binary got over in 6.2 itself. They merged with, and it was the same binary between Splunk for Linux and Hunk. It was just a different naming convention. The compilation was the same, the binary data was same internally, and then they merged the entire branch code into a single product. Then comes, once you get the data in, you are searching, you are replicating your architecture set. So what are the different filtering results options? How do you filter the data? You have phenomenal amount of events coming up all through the time. So you have commands like a search, where, sort, and rex. They're one of the most commonly used, commonly asked questions within the interviews. So search is an explicit, or rather I would say an implicit command which your search begins with. So it's actually lit search, and then it converts into a search command, and then that's not visible to anybody when you run a search. However, going forward, if you want to search for very specific keywords within your search results, is where you will pipe your results and say, all right, I want to search, commands or results or certain text with these keywords. Whereas where and search at times can be used interchangeably. Where provides search provides furthermore is extendable, whereas where clause is limited only to providing constraints like where client IP, count of client IP is more than 1 or more than 10, or whether the temperature is higher than 65 degrees or not, and things like that. So that's the difference between search and where. That's another common question that's asked in interview, like do they really understand the basic Splunk development part of it? Then there is a sort command which does a reverse sorting and ascending descending orders. It also has the capability, the sort command also has the capability to limit the results while sorting. So you can say sort 5 minus sales, so it just gives you the top 5 revenue generating products for you. The X command basically allows you to extract data or particular fields from within your raw events. If you have data which is already in, maybe historically it has come in, you could not identify the right way. X commands allows you to break down things like, if you have an email ID like mitesh@edureka.co, and then you want to break down Mitesh as a user ID, edureka.co as a domain name, and Edureka as a company's name. You can use Rex to really break down, dice your events and parts of each of your event records in the way you want. So those are some of the commonly asked questions around this. Of course, there are about 140 plus commands in Splunk. It's not practically possible for everyone to remember each of them and syntactically present them as well. But these are something from an interview perspective. People who have been doing a lot of searching and reporting, they would be able to answer these questions, and that's what the real test of an interview is. So you just want to see whether the person knows he has been working or not. Apart from that, knowledge objects, we saw something called as a lookup command. So there is a lookup command as well. which allows you to, and that's another area where most interview questions also dive into, that how do you enrich your raw data with external lookups. So you get a CSV file, and it's more about a use case scenario discussion during the interview, where you say that, all right, I give you a lookup for certain product catalog, and then how do you find and match the data between my raw data and the structured CSV or JSON data. So lookup command is also one of the areas. So it's more about mentioning the use case, explaining, and trying to understand that as you use it. Does the person understand whether there is a command called lookup, or lookup is just a concept that is being understood in the books. Apart from lookup command, there is input lookup and output lookup. So an input lookup basically takes an input, as the name suggests. So it would take those product price, product name input, and then match it with an internal common field like a product ID or an item ID. Whereas the output lookup is used to generate an output from the existing field list. For example, if you want to create a list of all your machine names, then you will say, all right, output lookup host file, and then you want to create a table of host files, and then you take it out. That creates a CSV file with the name host, and then you get the entire list of hosts in your Splunk environment. So people use input lookup to enrich the data and output lookup to build their information. So you can do that for comparison purpose perspective as well. So you want to take an output lookup from one set of data and then use it as an input to another set of data, and then compare the two and find a difference or find a common overlapping information. So certain use cases which are very unique are something that would come out in an interview. Eval and stats basically are one of the most common as well as the most important commands within the Splunk SPL language. And that's where they are being used same way like your search and where commands. At times eval and stats are also being used interchangeably. But however, there's a subtle difference between the two, whereas stats command is used for computing statistics on the set of your events, whereas eval commands allow you to create a new field altogether and then use that field in your subsequent part of your searching the data. So that's one of the very subtle difference between the two. And at times people do not really understand this because they know what eval does. So you can create a new field and you say field name is equal to something, and then you proceed that. However, the underlying structure is very different when it comes to knowing the technical difference between the two. So that's a great interview question, and that's one of my favorite questions as well, which I do ask at times when I get a chance. Another set of commands is like stats commands can also present information. So it's a reporting command. Apart from that, you also have chart and time chart. And that's where most people do not really understand. And it's a very tricky question in terms of interview, that what is the difference between a stats chart and time chart commands. An area where a stats command would present the information in tabular format, chart would probably give you a bar graph, a line graph, or an area graph. And a time chart also allows you to look at a bar graph, line graph. A chart command has an additional capability of giving you, I would say, a pie chart, which is not possible in time chart. A stats command takes as many number of fields to build a table for you. So you can create, server-wise, user-wise, IP address-wise statistics. Whereas a chart would take two fields because it creates a chart out of it. So you need x-axis and y-axis. So it can only take two fields. And it needs two fields, so it cannot have more or it cannot have less. And on the other side of it, the time chart only takes one field because technically the second field is always, your x-axis is always your time series, your time window. So whether it's 24 hours, 24 minutes, 60 minutes, 1 year, 1 quarter, 3 quarters, whatever it is, but it's a time series. So it's a time value on x-axis, and the second field is whatever you provide to calculate. So that's a subtle difference between the stats chart and the time chart commands. So what are the different data inputs? This is something that somebody who has worked as a Splunk administrator and is experienced in it will be able to answer from an interview perspective. So of course there are files and directories, but then there are network inputs. People generally stop at that part. Some people would step ahead and say, all right, I can write scripts and take an output of those scripts and push into Splunk. A seasoned administrator would add the fourth option called as Windows inputs. So Windows inputs are a fourth type of inputs, which is very uncommon from theory perspective, knowledge perspective, while they might be using those options, but they do not know the category of that. So your registry inputs, printer monitor, network monitors, Active Directory monitoring, all of these inputs fall under the Windows inputs category. And that's another great interview question as well. So once the data is in, you know where they have come from, what they're doing. There are certain default fields that are kind of barcoded with every event, and you cannot change that once they are in. So that's very important to know, because incorrect settings or incorrect naming them and terming them would lead to a catastrophe. You will not be able to really get and understand what you are really looking for. There are about 5 fields that are default, and they are barcoded with every event into Splunk. One of them is host. The host is a machine or an appliance IP address name from where the data is coming from. That's a host. That's a source. The next one is where on that host is our data coming from. So it's UDP 514, or whether it is a path within a machine or a shared drive. So that's the source part of it. And then there is a source type. So what is the format of data? It's an XML, CSV, it's a log file, log4j file, is a thread feed, what kind of format it is. So it's a source type part of it. And then you have an index name, the name of the index where the data is going through. If you don't mention anything, it goes into a default index. And then there is underscore time. So Splunk is basically a time series machine data collecting tool, so platform. So underscore time is a hidden in field which is barcoded with every event, and that cannot be changed. You can rename it, you can dice it over a period of time. You can use eval commands to change the presentation and look and format of it. But underlying on the raw data, once these event fields are written, you cannot change them. There's no way to change this. And it is important that person understands this if he's really an administrator or an architect for that matter. Once the data is in, so you would want to create an alert, like we saw from the architect slide, that you can create alerts. So what is an alert, and what are the different options of setting up alerts? So what is an alert in Splunk is another area where, and is aimed more for Splunk administrators. So people who really work with data, they need alerts in timely manner. They want to know whether the data is coming correctly, or whether there are certain rules and triggers that need to be fired up in case of certain conditions are being met or not met. So like a file coming in at 5 a.m. sharp is something very crucial for the business application to proceed further. And if it doesn't come, they need an alert. So at 5:05, you need to trigger an email or a ticket with high priority to certain group of machines, send out a pager message. So alert is basically a trigger and set of workflow actions internally which are fired up on a certain condition being met, I would say. So that condition could be like missing event or extra data coming in and things like that. So the different options that are available when setting up alerts are that you can create a webhook. So you can write to something like your hip chat or a GitHub, or you can write something like an email to a group of machines with all your subject, priority, body of the message, and things like that. So all those 7 fields that ITIL requires to trigger an email are present into it. So you can add variables, you can add your results as a CSV or PDF or inline within the body of the message to make sure that the recipient understands where this alert has been fired and under what conditions and what's the action that he has to take. Apart from that, you also have the ability to create tickets. You can throttle alerts based on certain conditions like a machine name or an IP address. For example, if it was a virus outbreak, you do not want every alert to be triggered and creating a ticket in your system. That will be an overload. So to make sure that it's being controlled and throttled, you have the ability to control them from the alert window. So those are certain options in setting up alerts within Splunk. And most of it is like kind of during the interview, you would expect just 1 or 2 options, because not all of them are being used all the while. The person may not have exposure or the ability or have a chance to leverage these options. If the person can answer just 1 or 2 parts of it, that's a good sign. This is one of the most important things from troubleshooting perspective for an administrator as well as an architect, for that matter. To an extent, even a developer would depend on this particular information. It's called file precedence in Splunk. The entire set of configuration in Splunk is written within plain text .conf files. Now, each of these files could be multiples in copies, and it is important to understand how these take effect into Splunk when it is running or even it's restarted. So file precedence is something that one has to understand, and then that's how you will be able to plan your upgrades of Splunk or the app, or you provide different data inputs and set your configurations and deploy those settings across your Splunk deployment. So one of the most important thing and the common ways is like, of course, you can go out to a user level, preference level settings, but the most common answer is at a system level and at an app level. So that's where we normally expect the candidate to answer them with this particular question. So it's like Splunk Home, HC system, default, local is the default is the highest one. Then comes your app default, you have an app local, and then the system local. Now from a deployment server perspective, if you look at it, the file precedence of system local cannot be modified. Deployment server cannot touch the system local settings. So even if you push a lot of information in there, all right, I want to say that my load balancing must be between these three indexers, and that's not taking place, have a look at your outputs.conf or a particular configuration file within system local directory. There is some file which is overriding the capability, and then that's not being able to take effect, letting your deployment take effect. So file precedence is extremely important to understand when you are troubleshooting perspective. So if a candidate can answer and if he understands file precedence, so the moment you say file precedence in Splunk, that's good enough. So there's no what and where and why and how. Even if just ask for, can you explain what is file precedence? Even if he can explain that, that's a good sign. Extracting fields is another great thing. Splunk has a lot of inbuilt intelligence within it to extract fields based on certain characters that it finds within each of the events. So equal to sign, semicolon sign, braces, brackets, curl brackets, round brackets, square brackets. It can understand those opening and closing of loops, and then it can extract fields for you automatically. Of course, there is a UI way of doing it from multiple places within the event list or from a sidebar as well, or you can go into the settings menu and do it as well. The most complex and nerdy way to do it is to write your own regular expression in a configuration file called props.conf and then build it up for you. So if a person can understand and explain how do we extract fields automatically or how the sidebar being populated, that's a good sign. He understands Splunk. The other way to do it and understand, a double click on that would be to ask if he understands search time versus index time field extractions. So a search time field extraction is normally the sidebar being populated when you have, when you enter a search, you say index is equal to demo, and then you source type as your web server data, and then the sidebar is being populated bytes and user agents and IP addresses and usernames and things like that, status messages. And index time field extraction typically happens when the data comes to Splunk. So right between the data source, and so you can set those index time extractions on the forwarder level, or you can set it up on the indexer level as well. So most of the times it is on indexer at the time of parsing stage of getting data in. And they are hard-coded, they are part of the metadata. Search time field extracted fields are not part of the metadata. So they do not consume your disk space, whereas index time field extractions consume your disk space. So that's the difference, main difference between the two, apart from at the stage at which they are being calculated or computed. So how does the data age? The data is in, you have been using it, you have extracted, you have created reports, you have created knowledge objects, fantastic. So now you need to age out the data in Splunk. So the next logical question that comes up in the interview is that how does data age in Splunk? And that's a set method since I have seen 4.3.6 about 4 years back, and it hasn't changed, and I don't see a foreseeable time when it would change as well. So that's a set way of the data coming into within an index is broken down into buckets. So that's the granular logical store within an indexer where the data is written. The first place where it is written is called a hot bucket, and the file directory starts with hot underscore db and things like that. Subsequently, the hot bucket, as the temperature cools, the hot becomes warm, and that's the bucket which is not written, but it is being actively read. The warm bucket, once it becomes a little more cooler, goes into the cold bucket, and that's the data which is historical, not often touched, and that's most of the times is like kind of used only for analytical purpose, quarter on quarter, year on year, kind of year-to-date data analytics. And then once the data completely ages out, it gets moved into frozen bucket, which is not touched, and if you don't set a setting, then it would kind of delete that within a certain set of days. The new feature within 651 is that you can point your frozen bucket and age it out into your Hadoop HDFS system and keep it searchable, which so far it was not. With 651, you can push it into a HDFS directly and keep it searchable. So that's how. So even if a person can explain hot, warm, cold, and frozen, that's good enough. The 651 is extremely latest, like just 2 days old, so not many people know about it. Summary index is a great another question, mainly from an administrator perspective. So summary index is something where a question where people want to know about how do you store your analytical data when your data is aged out. So that's the biggest advantage of having a summary index. You have aged out your data. Your data retention policy is only for, let's say, 6 months. So your data is past 6 months, beyond 6 months. So you still want to do a year-on-year calculation, or you want to dig out certain statistical values. So summary index is useful in that particular concept, that you store the summary and statistics outputs, saying that, all right, my percentage growth or percentage number of sales that took place within past 6 months, and I just want to store an average revenue on top of it. That average values are stored within summary index. So that's the biggest benefit. Now, the other area where summary index has a limitation on the other side of it is that you cannot do a needle in the haystack kind of use case. So you cannot drill down and say, all right, let me find out which product contributed to this revenue. You cannot find a top product from that summary statistics. So you cannot drill down and nail an individual event which contributed to that summary. Apart from that, summary indexing is great for analytical perspective. So somebody who can explain the two parts of summary index in terms of what it is for and what is the limitation for it, or I would not say limitation, but it's kind of a lower point on the score about summary. That is a good score to say. Not all events need to be excluded. So how do you exclude and drop certain events from coming to Splunk? Now, use cases out here are typically debug messages in your application development cycle. So you have that ability to say that, all right, any event which contains debug, you can put it into a null queue. So that's a particular queue, and that's put into transforms.conf at the forwarder level. If a candidate can explain that, that's a good score. That's a pass, I would say. Time zone is extremely important when you are searching for events, because if you're looking for events, particularly from security perspective or fraud perspective, if you are selecting a wrong time zone within your events, you end up not being able to find that particular event at all. So the default time zone is picked up from your user setting and the browser settings. So when you go into the browser and it picks up your current time zone on the machine that you're using it, that's the time zone that it picks up within Splunk when you're getting the data in. And it is required the most when you are searching and correlating data from different data sources. So what happened at 4 p.m. India time in your Phoenix data center or a Singapore data center, the time zone would matter a lot in that particular case. So if you want to correlate events at a particular time zone property is very important to be set. And that's the most crucial event, is the security correlation event, when it is required the most. Or when you're doing financial analysis, week on week, day to day SLA monitoring, financial revenue monitoring. Those are some of the use cases where time zone property of an event is used the most. So all of these put together is a Splunk app. So your reports, dashboards, alerts, field extractions, lookups, all of these you put together is an app. Subtract the visual interface of a report or a dashboard, and what remains with you, your lookups, field extractions, become an add-on. And any candidate who can explain this in as simple terms as possible is the kind of person who is, I would say, I would then take him, or rather question him further on the developer path. So he is a great guy. He understands Splunk. He understands the structure of Splunk and what are their collections are. I can see a question coming up. A great thing. Thank you so much for that. So Dinakaran says how time zone is calculated. So time zone is calculated when you enter props.conf has something called as TZ. So it says, let me just put that for you and say that it's props.conf has a stanza called TZ. I'll send this to all so that people know about it. So you set this value and then you say that it's America / California, or it is Asia / Kolkata, and that it picks up that particular value. If you cannot find it, then it tries to guess a time zone of that particular. So it picks up the time zone of the host from where the data is coming from. So if you don't mention this, then it's a host time zone that it tries to guess. But the more information that you give to Splunk before the data comes in, it is considered extremely efficient way of getting data in. So it doesn't have to do guesswork. So it's like asking for a food in a restaurant. So you say, I want some food. The waiter would, the bartender would try to guess what you really want. And then he will give you different options. And then you will say, all right, I want a sandwich, or I want a burger. And then you'll say, all right, I want a vegetable sandwich. I want no eggs, no mushrooms in it. The more specific you are, the better is the recipe to your taste. And that's the principle where Splunk works on. Great question. Thank you so much for asking that. What's the use of a license master? A master is a master, so it is important, of course. And the license perspective, it is important in terms of making sure that the environment is within the limits of the purchased volume. So Splunk license is based on the data volume that comes to the platform within a 24-hour window, the peak data volume. So if you are saying that within a week you have data coming in like 300 GB, and then someday you get 500 GB, and then next day you get 1 terabyte of data, and then it suddenly drops to 100 GB. So the ideal size of the license should be 1 terabyte. That's a peak average that you have. So the license master makes sure that the indexers within the Splunk deployment have sufficient capacity and are licensing the right volume of data. Now, in case the license master is unreachable, getting data in does not stop. It's just that it is not searchable. The data continues to come within your Splunk deployment. Indexers continue to index data as they would normally do. Just that you will get a warning message on top of your search saying that on the web UI, wherever you are, saying that you have exceeded the volume, and then you either need to reduce your data coming in or you need to buy higher capacity of your license. Splunk 651 has something called as no enforcement license, which means the message would come, but it would have a different set of implications. I'm here to study that, but overall you would say that the indexing does not stop. If the candidate can answer that question, or you can answer that question, that part, you understand the licensing aspects. So once you exceed, there is a license warning that is thrown up, and then that persists for 14 days. And a rolling window. So if on a commercial license you have 5 warnings within a 30-day rolling window is what a license violation is considered as. And that's where your Splunk Web would present you that warning. We spoke about that in the previous question. And then your index, the search reports alerts would stop triggering at that point of time. So that's the license violation. On a free version of Splunk, that's 3 counts. And in a commercial version, it's 5 counts of warnings. The 5th count is a violation. A little more of cosmetics. When you're presenting data, of course, you all want colors, and typically it is RGB, red, green, blue, but then you don't want the red to be the first, you want the red to be the last one. So if it exceeds a certain value, then you want the red one. Or if you are not having enough sales, should be the first one. So how do you change those colors in Splunk Web UI? Yes, typically when you have those panels built onto a dashboard, you will edit the panels and then you will modify the panel settings from the UI. Now, a question around is that how do you assign colors? Is pick and choose, of course, and then there are range colors, range command, which allows you to provide palette hexadecimal values in your code as well. You could do it that way too. Generally, Splunk UI is the most common way, and you have the flexibility to give different colors to different value-based pipes in your bar chart or a line chart. You also have the ability to give different gradients into a radial gauge or a water gauge as well. So you have that ability to give different colors, and they work seamlessly all across. The same command works in the same UI. Even if you change the representation, the scale works the same. So that's one of the questions that I would ask if somebody is kind of working on dashboards, writing different searches, and I want to know, is he inclined, or I find him confused between being an administrator or a developer? Then that's the time that I try to understand that. Have you played around with the dashboard options or not? Or you've just gone ahead with what was given out of the box? And comes a question which is typically around, if you really want to grill a person and try and ask him what is a source type, how do you explain a source type in Splunk? So basically, it's more about the format of data in which it comes in. Now, source type can be set at the forwarded level for index extractions. So when you say it's like the source type is CSV, but CSV would have its own different ways. So you would say that, all right, my first line is a header and my second line is a blank line, and then where my data really starts. You have probably somebody has converted an Excel file into a CSV. Then you want to set your source type. You can customize your source types. There are pre-trained source types within Splunk, which are roughly about 40, 43, 45 in count. Most commonly known things like even asterisk EPBX or Cisco's and Javas of the world have been very well known to Splunk. It has almost 95% of date time capabilities which it can identify and tag with your source type. So unless your date is broken down into 3 different columns of a CSV, then that's where you would want to set your source type and say that this my source type has my date time fields broken down here, and it has these characteristics. That's what you call your source type as. And that's somebody who has really worked as an administrator, whacked his brain into different data types, is when the person will really be able to explain the finer points within a source type. So I find somebody, if it's like I feel that yes, this candidate is the one that I should be selecting and I want to take a call, then this is a trump card that I would play. What is a source type in Splunk? Explain in little detail. While it's a single line would be like format of data coming in, but then how do you define that format? What are the different parameters that you would define that format for? And the most important is the time factor. If you can speak about a time that and give that kind of an example, then it's a great thing. It's a great response. So that brings an end to the kind of question bank on Splunk interview, which were mainly aimed around architect and administrator. And we, over a period of, I would say it's more like a journey that we try to build a story out of it, seeing that where do you see a person really, a candidate really doing well in which kind of area, and you can branch out the next set of questions to ask, or you can judge that if I'm not confidently answered that question, the next question probably would be this for me. So that was from our side. If you have more questions, we are happy to take them for you. And of course, there have been great interactions so far. I really appreciate those questions coming up. So I just want to make sure that I haven't missed out anything so far. Just check. Map reduce is done. Competitor to IoT is done, is answered. Storing data on HDFS is answered. Best practice for clustering. Okay, another question from Dinakaran is, how do you use geographical maps in Splunk? There are 2 types of maps which are available. One is geospatial map, a standard map, MaxMind database, and then there is a core map, which is more about you can plot your own areas on a map and then you can show them. So like a security attack, or not only security, but you can also use it like you want to see statistics of sales per product in a particular region. You could do that as well. So even from analytics perspective, geographical maps are useful. IoT area also it is useful. You want to plot your GPS or RFID tracker and see where the vehicle is moving. You could look at that, or how it has moved. Exploratory ships are great way, another source of data, or planes. Aeroplanes are also a great source of such maps and uses. So there are commands like you can do an IP location, client IP, and then say geostats count by product, and that gives you a statistics, a pie chart on your map. Or you could do a geom and say a feature ID and say that I want to see the heat map, who's winning in which state for an election. That also can be possible. So geom with feature ID and geostats with IP location command can be used. Great question. Alternate to predict command is not there yet. Yeah, you do have a predict command in Splunk, but it's not there yet. Not at least within Splunk. Within Splunk, it's not there. Otherwise, you could build your own predict command using either something like a prealert or R capabilities, statistical tools. You could probably do something outside Splunk, but within Splunk, you don't have an alternative right now. Yeah, it's doing a fairly good job, so I don't see anything else getting developed as well. Machine learning, I don't see a lot of it from an interview perspective. And these are more of a product capability perspective, but From an interview perspective, we don't see that much coming up. How effective? So 651 is 2 days old, so I don't really know. Right now, I would say, how does that really work? How good it is in 651 machine learning? Great question. Good to know. People are interested in machine learning. We'll see a lot of traction in machine learning area for Splunk development going forward. Interview questions on SIEM or IT operational intelligence. Generally, it's more like a UI, so it's more about use cases that a person can build, and one has to know, does he really understand Splunk well? So this session was more about, the Splunk basics, the Splunk architecture perspective and administrator perspective. It was not a use case specific, so we kept it as generalized as possible, making sure that we cover as many audience interests of as many audience participants as possible. Mostly it is around competition and capabilities of what it can do and what Splunk cannot do versus legacy technologies in those two lines of IT ops and SIEM. Dinakaran, yeah, I can. How to explain? So Dinakaran has a question about how to explain elk versus Splunk in an interview. So we spoke about that. So at times, what happens? Elk is also growing strategically into a commercial area slowly. It's a combination of three different products: Elastic, Logstash, and Kibana. Storage and the number of instances in elk is like 10x more than Splunk. Number one. Number two, I would not get beyond just the open source and a commercial product that way, because it's like comparing apples to oranges, number one. And number two, product features keep changing. Today, we see no enforcement license on Splunk 651, whereas it wasn't there in 6.4, just one version back. So comparing product features across competition is not a good thing generally, apart from what the basics and the market would say about it. But really, it's not a good idea, and if possible, try and dodge that or explain it the same way. Product features keep changing, so it's difficult to really keep track of competing product comparisons in as a chart all the time. You will just end up doing that as such. Any other questions? Search versus sub-search. It's generally not an interview question. For that matter, we haven't seen that in a while. So, like I said, there are 140 odd commands, and we don't expect people to know everything and every question. So it could be these are the main questions that we see in the market in terms of interviews being done. In terms of explaining the differences between search, sub-search, stats, event stats, stream stats, there are a bunch of documentation available. We do cover that in our course as well, and a lot of them would come up in our blogs too. So if you go to Edureka blog sites, you'll get that. But from an interview perspective, we don't see those questions much coming up. We did have that question in our bank to see if we could cover that, but we haven't seen that question coming up. Another question, how do you optimize performance in a search query? Generally, a search performance is largely hardware driven, number one. So the first thing that I would look at is the IOPS on disk. If you have slow disk, if you have SATA disk or eSATA drives, throw them off. Get rid of them, one way or the other. Move your data to faster drives, either SAS drives or solid state drives. That's the first thing that you should do. So you keep your hot and warm buckets on solid state drives, cold buckets on SAS drives, and frozen buckets on SATA drives or HDFS, which are the slowest. That's the first thing that one would do. And then subsequently, there are certain commands that you would see, and make sure that your transformation commands or things like renaming commands come at the last. You try to filter out the results and provide as granular search request as possible. Index is particular, Splunk server is particular, you want a source type, you want a source, you want a host. Try to avoid greedy searches like putting asterisk stars in your searches. Don't say index is equal to star. And the best way to optimize your search is basis your time window. So don't search all the time. Specify time window when you want to look for the data this week, previous month, previous year. Be very specific. from the time window perspective, because that's how your data is recorded, is stored on your drives, and that's how Splunk will search it. So the specific data that you say, the better it is. If you're just analyzing or testing data, you can just say, just get me 5 records, good enough, 10 records, good enough. I don't want 10 million records, because I'm just testing the integrity of my data and the quality of my output. That's so 10 records or 20 records are good enough, or 100 records are good enough. And that's how you'll optimize your performance. At most of the times, even from a customer perspective, you will never click on page 2 of your results. So try and see that you have as limited results to make your report as meaningful as possible, and that also in a way optimizes your search query. What is a website to have more info on use cases and good dashboard? I'm sorry about that, Dinakaran, I could not get that question. If you could elaborate that, or maybe just samples, Splunk app, samples. All of them are great examples. All of them have one learning or the other. It all depends upon what you really want to present. Sample search query with dashboard. There are a lot of them so out there. Go to splunkbase.splunk.com and you should be able to find about 1,400 different app and add-ons, premiums and free both. Well, we are on top of the hour for now. I will just take one last question if there is anything, or we call it a day for today. Sure, go ahead, Dinakaran. Explain about myself. Okay. I did explain that at the start, the majors. So I would say commerce graduate from Mumbai University with 20 years of industry experience, with experience in leading a startup, which was I was officially employee #1 for Splunk India 3 years back, and then my majors or major skill sets have been into security consulting, Six Sigma, quality, process champions, and Splunk, of course, and then a lot of different domains. With Splunk, you get a chance to work with probably all the domains. I worked with travel, I worked with hospitality, I worked with transportation, worked with security services, enterprises, retail, a lot of them. That's all from our side for today.
Please be kind enough to like this video, and you can comment any of your doubts or queries, and I'll reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning.